Firstly, I'd like to say thanks to Andrew and DAMA for having myself, Kevin Maxwell, CEO of Exemplify, and Michael Lane, who's down in Melbourne, joining us. He's one of our NVIDIA partners. I would kind of like to describe him as the guru army of everything AI and what NVIDIA has to offer. So between his expertise and my kind of perspective coverage, I think we're in for an interesting evening. First, I'd like to also offer my acknowledgement of the traditional owners of the land of which we are meeting tonight. So here we're on the lands of the Ngunnawal people, and Michael's on the lands of the Wurundjeri people. I'd like to pay our respects to elders past, present, and future as well. So tonight, it's an interesting one, right? So for DAMA and thinking about data management, data assets, and then think about our worlds, and I can talk a little bit about Exemplify maybe towards the end, but also we'll go into NVIDIA. I'm sure you've already heard of NVIDIA. We actually want to talk about what businesses and governments are doing right now and the challenges that they face, and then how, in terms of how we set out this presentation, the kinds of considerations and thought processes needed to make sure that as data scientists, as people that work with data every day, can fully embrace and harness AI. So the abstract that Andrew kindly put out as the teaser was really around how to think about getting things right, getting the execution right, which at the end of the day, in all things technology, it's about the execution. But also, what's the effective enterprise data science and AI platform? So how does all that come together? So our aim for this presentation is really to talk through some of those considerations about the requirements, the opportunities, the challenges, all the stuff that you see day to day, I would imagine, about how to bring enterprise data science and AI platforms together, and also some of the benefits around those enterprise cloud solutions, etc. So I might just jump to the next one. Thanks, Michael. So obviously everyone's a massive reader of The Economist, like I am. Fantastic covers they always are, but data fundamentally is the new oil, right? So you can extract it, but then you still got to process it. You still got to do things with it to actually get the value out of it. Hence, that's one of the reasons I love that cover on the left there. That processing part is really where the value comes out. So sure, there's a lot of investment to get it out of the ground, but you still can't sell it, or you still can't grab the insights out of it. So businesses face new challenges in terms of that operational and business models and modalities needed to be able to make that step to get that value out of it. And so if we go to the next one, what if? It's a great question. As a former management consultant, I used to ask why 5 times to be able to get through to the fundamental problems of things. Michael, what if?
Yeah, so I love this question. So in a previous life, I made a mistake and got a degree in philosophy, and I learned that the questions you ask really define the answers you get. So we're going to go through a bit of frameworking for sort of questions, both in a business and AI sense, but we're really talking about doing things in a very different way. And this is where data scientists often have the challenge of communicating that it's not just a new computer program that does something slightly differently. We're talking about an algorithmic business. So we often hear people say, oh, we've got a digital business, that's fine, we've got a digital platform, we're digital ready. It's like, that's just the foundation for data science. So this what if really takes it to a very different level, and asking businesses to look at how they do things, whether they're inward focused inside the business in an operational or process way, or whether we're outward focused to customers and things like that. We're looking at things in a very, very different sort of fashion here. And that sort of plays into this as well. So I'll talk to the left of this just for a second. So, AI is a very broad term, and we find there's different levels of understanding in different businesses. So, we get some customers who say, oh, look, I'd like to buy some AI, in the same way that they would have thought, several years ago about buying some cloud, But obviously, depending on what you want to do, what sort of business you have, and what your skills are, and that skills piece is really important. There's lots of different areas. So a lot of it started with computer vision, or CV, which is great for visual streams and recognition of either ongoing video streams or pictures or imagery and that sort of stuff. There's different types of learning. So we've got supervised, unsupervised, reinforced. It's coming into the robotics space as well, especially when we talk about supply chain and automation. And then we get into some of the really, really fascinating human interaction pieces here. We talk about natural language processing, one of my favorite areas, because it's the human-machine interface, which is very, very different versus bots doing things by themselves. And that's could be text-based, could be voice-based. Hey, we've all got the likes of Google and Siri and that sort of stuff. But the power of those inside a business is really, really different. So depending which of these you have, you get different sort of use cases, on the right-hand side there. And Ken, I'll sort of throw back to you for a bit of discussion on those ones.
Thanks, Michael. So one thing I'll note is that Andrew's going to pop their slides up on the DAMA website later, and hence you'll be able to really see the detail. You can't see, you can't read from where you're sitting at the moment. But on the right, so what are the different kinds of use cases that when we think about the spectrum of artificial intelligence, so we're thinking about tax, fraud, healthcare, COVID safety, cybersecurity is obviously a very big one. How I think about workplace assistance or workplace assistance and security. Thinking about social media monitoring, supply chain management. It's a great little graphic there, so I definitely encourage everyone to jump on and have a look at it and jump onto that website as well. But really, what are we doing with those use cases? We're kind of starting to ask questions, right? We're asking the question around, is something there? So is cancer there? Is there cybersecurity? Do we have a problem? Do we need to find something? What is it? Is there some sort of trigger or security breach, whatever it might be? To what extent is it present? So thinking about actual measurements, so things like health, risk assessment, environmental measurement, all those kind of domains. Thinking about outcomes, predictions. Thinking about, so in the case of fraud detection, so how early do we want some of those warning bells to be going off, and hence the predictive analytics. What will satisfy the outcome? So from a prediction point of view, thinking about things like autonomous vehicles, driving, thinking about weather, those kind of areas. And then natural language processing for contextual analysis. So AI assistants, bots, all that sort of thing, feeding everything else. So that's, again, what we're trying to set up here is just trying to get you thinking around what the art of the possible, the what if, and again, not being constrained in our thinking. So if we go on the next one, thanks, Michael. Probably articulates it well. So anyone that's got a science degree or has been through a physics kind of approach to things, you'd be familiar with the future cones. So we're always constrained in what we think is the kind of the probable, but how do we actually expand that cone? How do we think about what could be the art of the possible, or what is actually preferred, or what is plausible? This applies to AI in the fact that it offers different, new, valuable outcomes and capabilities that organisations can now be leveraging, and people like yourselves, in thinking about how you go about your day-to-day work, or your companies, or your departments, or wherever you apply your trade craft and skills. What could it actually be? What is the value that you could be having if you're thinking these different paradigms? And hence, yeah, it just reinforces that art of the possible question. If we go on, again, I mentioned quickly before in my old roles as previous to being a CEO of a tech company, thinking about solving problems, thinking about how to step through problem synthesis, etc. You kind of go through this normal kind of canvas approach. Like you think about what's the problem, needs, what the stakeholder aspects, value sought, what's the change of focus, what's the solution that comes out of it. And there's many different ways to think this through, right? It's just a technique or a way of thinking through an opportunity or how to solve a particular problem or challenge. But what's really interesting in this one here, the detail here is a mock-up. It's a dummy around how to think about modelling budget estimates in government, across government, whole government. You can pick whatever you want, but the words here are just an exemplar as to that kind of thinking. What's really interesting here from the AI point of view and thinking about the application of AI is that bottom right-hand box here around the game-changing nature for stakeholders. So the how around AI really comes into its own here. Stakeholders, in thinking about AI or thinking about this new technology, we're not thinking about it, or no one's thinking about it as a traditional ICT technology. No one's going to the ICT division, department, group, whatever it might be, and say, we're gonna do some AI. It's always done separate from, right? Because and hence it's always thought about it's something the business is bringing, or it's not traditional in terms of ICT in its current form or its current maturity cycle. And hence that's where, if you now start thinking about the game changers for stakeholders, it's different as to who the stakeholders are and how you're engaging with them and why you need to engage with them. So if we think about that, if we think about those stakeholders up here, we've got digital workforce, IT automation, cybersecurity, network storage, database, compute infrastructure and platform. But we're thinking about the entire ecosystem around this, again, non-traditional ICT. We're thinking about governance. So how are we going to govern if AI is stood up in a stovepipe versus stood up for the entire department, company, whatever it might be? How are we thinking about all the things that you think about on a day-to-day basis, from data? What is the source of truth? What's the provenance of the data? Things like overfitting AI to what a data set could be, and hence the correct application of it, or even the problem of AI as a black box. So how can the appropriate governance and regulatory kind of apparatus and frameworks sit across the top of AI when it's that non-traditional ICT? So all that thinking needs to come to the table now. Skills are part of this as well. So what skills do you actually have? What skills do you actually need? So doing the algorithms versus supporting the computational infrastructure versus thinking about how it interacts with other data centers, how you think about cloud deployments, how you think about ORAP assessments, all that sort of stuff. What are the skills in your own workforce versus when you're choosing to buy them out in the market? And from the infrastructure point of view, this is not a standardized a standard enterprise stack, right? We're talking different kinds of infrastructure here, and really, it's great to be able to work with companies like NVIDIA, which we do. We're very partnered very strongly with, for them to be able to bring that expertise, that global expertise to the table on a day-to-day basis. So what's the data infrastructure requirements around connecting between compute and the edge, for instance? Infrastructure, obviously, in an entity or a company or a department wanting to get into the AI space, you're not going to be a Google from day one. You only need to kind of build up to that kind of scale. So hence your future back approach around what do we want to be and how do we want to be successful using this new capability? How do you work back from that and go, well, how do I get to that? So what are there thresholds, are there barriers to entry? And I would say that something like AI infrastructure or enabling infrastructure is one of those. And hence that'll be my plug at the end around how Exemplify helps in that way. But that is definitely a barrier. So you just can't go and start doing AI on infrastructure tomorrow and get these outcomes. It's a growth path. Michael, do you want to add in on that?
Yeah, and I think you've really touched on a couple of interesting points. So, governance, skills, infrastructure. One of the biggest barriers we find at NVIDIA as a provider of infrastructure is that too often this whole AI, open source, GPU intensive stack is really, really hard for traditional IT because it's not Windows and it's not VMware, right? So what it often means is that data scientists are often stuck building their own kit. And apart from, that's the enemy of time to value because you're not necessarily infrastructure people. It also means that this whole, taking a look at the life cycle here of this opportunity canvas is not often considered throughout the whole business. So again, we miss the governance layers and that sort of stuff. And that's really, really problematic. And also it means that you've got challenges with data security and data provenance and all sorts of stuff in that space. So this is really designed to make sure that whole of business assessment is there. And of course, as Ken quite rightly pointed out, we can fix infrastructure fairly rapidly, whether it's learning or inferencing or whatever it may be, from a supply perspective with GPUs as a service. But that allows a data scientist to focus on what they do and skill up and get some extra bits and pieces if they need to, and the IT team to focus on just plumbing, right, which is a little bit easier. So that's it's a really big thing because the whole governance, AI ethics, how our algorithms change the business, you want those to be considered. So it's really, really important to have this whole of business view, even if the workload itself is siloed. Let me just tackle that. So one particular example. So we talked before just briefly about AI as a black box. So what are the problems with AI is when you go through a training system and train a neural network to see a cat, cat not cat, hot dog not hot dog, whatever you want to do. Of course, it's 97% versus 0.1%. One of the challenges is it can't explain to you why. And this is one of those ethical concerns in AI, which is, computer says no. Why did the computer say no? Don't know, it just said no. So this is a really interesting example of how one of our customers actually deployed this and used the computer can't tell us why as not a problem. So what they did is when it came to claims processing, think about, we just had some hailstorms here in Melbourne. So imagine damage on that, or floods or fires, or all the horrible things that have happened to Australia over the past couple of years. When you get large quantities of claims, you need to process them all really quickly. However, people are bottlenecks. But most of the claims, they're simple. So what we want to do is automate the simple ones so the computer can say yes, but the computer doesn't say no. It just, when it can't say yes, it hands it off to a human being. So this is keeping people in the loop. So what you get out of this is really awesome. If you've got a high volume, quote, low overhead claim, it just goes through. The money's in your bank account, automated, you get an email, text, whatever, it's all done, right? If it's a really complex one, people in the loop, they can do what they do best. So all these claims processors have been doing this stuff for years. They get on, quote, the hard ones. They don't, quote, waste their time with the easy ones. So this is...
Unless you're a client with NRMA, which I was in the hailstorm last year. It's like 6 months to get the car fixed, but
yeah. Correct, right? So
compared to Coles Insurance, which paid out straight away, right? So they're probably using the AI.
Well, actually, ironically, we do work with Coles on AI.
There we go.
Right? So this is one of those, how you go about it, lots of different things, right? But just sort of stepping back one step further on this and talking infrastructure stuff for a minute, hey, the D in DAMA is data, right? So let's talk about the data for a second. We have lots of customers who say, okay, we're ready, we want to get going. Oh, bummer, the data's not ready, right? So, we can talk about taking a data swamp into a data lake, and we can talk about, inferencing on our data streams and the like. But often one of the biggest challenges is customers need to spend a lot of time on the data, getting it ready, getting it manicured, annotated, whatever it may be, in the appropriate format. We had a customer here locally that was doing some medical work, and obviously training for medical imaging is a really big thing. And again, not to replace medical radiologists, but to assist them in guidance, especially in remote areas and that sort of stuff. So they said, yep, we've got several $1 million ready to spend. That's not on kit, that's just on outsourcing the annotation of the scans overseas where there are large quantities of medical radiologists to get our data set ready to train. And it took them about 6 months to get ready for that ETL stage, getting it all going. Then, of course, they had training, and then we went through, make sure you don't get overfitting, you segment out part of your data, and then go into a deployment. We used the term overfitting before, and for those of you who are not familiar with it, a best example I can give you is in the States, they had a neural network that was trained to identify wolves, and they fed through several 100,000 pictures of wolves, and in the end they got it absolutely perfect. It was finding wolves 100% of the time. They put it out in the wild, failed every single time, and the reason it failed, apparently in the wolf pictures they had, there was always snow. So the system basically said, oh, there's snow, it's a wolf, done, no problems, right? So this is getting your data right and making sure that you've got the breadth of data there. And this, again, coming back to some of the concerns we have around governance, if I can pick on medical stuff, where does your data come from? Is it segregated to a particular population group? And what challenges does that present? If you want to get multiple groups in data, can you actually put the data together? And usually the answer is you can't. So we've developed a system that does, so we've got a medical system called Clara, which does a few different types of medical work. And that actually can do federated training. So you can train on multiple different groups and it aggregates collectively, even though all the data was never put in the same bucket. Right? So there's all these different things we have to take care of, but data is always at the root of everything we do. The other bit here that's sort of implied, but not sort of mentioned explicitly, is ongoing management of that data. So again, the data lake, how you curate that into a training group, and how you take your data streams, your inbound sort of telemetry, as it were, not just for applying the inferencing and AI, but then feeding that back into a data lake, and then later on potentially retraining again. Right. One of my favorite stories was a couple of years ago, I think it was about 2018, Volvo had a self-driving car testing actually there in Canberra, and it was going down the road, and the Volvo cars have something called a LAD, or large animal detection. So it was going down the road and it went, yep, that's a horse, that's a cow, that's a sheep, all things are good. And then it saw a kangaroo and it went, yeah, no, I'm out, mic drop, and pulled over the side of the road. So they had to go back and show a whole bunch of different pictures and videos of kangaroos, train it. And kangaroos are weird because they actually leave the ground on a regular basis, unlike most animals, which is why the car was freaking out, because it looked like the kangaroo was teleporting closer and further away. And of course, now we're talking about edge cases. And what have we considered developing in one environment, applying into another, and so on and so forth. So it always comes back to this, governance and that sort of stuff as well, right? Which is important. Have I missed anything here, Ken? Have I covered that?
No, I think it's one of the challenges. So it probably goes back to that future back positioning of where what success looks like in terms of deploying AI in considering data, and hence the prep times, the whole life cycle to be able to get to that point needs the thorough consideration and thinking put through it. It's not just as simple as we said, you can't be Google overnight, right? So how is it structured? How is it governed properly? How are you setting yourself up for success in terms of a lot of that prep time and training, etc.
Yep, no, good one. And the next slide's interesting because it's actually about what sort of data scientists kind of do every day, right? So this is the standard question we often get asked is, hey, why are you GPU guys talking about data science? And for those of you who know, apologies for echolalia, but Alex in 2012 applied the code to his GPUs rather than his CPUs, and things have never been the same since with the big boom of AI, right? So we look at CPUs that have got 56 or 64 cores, all shades of awesome. They do a great job of running the operating system. Our GPUs have got up to 10,000 plus cores on them each. And when you scale those out, so the boxes that Ken's got there have got 8-way with our custom bus, which is 10 times faster than PCIe 4, and lots and lots of memory and so on and so forth. So it basically allows you to do science, and data science at its core is actually science, and it allows you to iterate more rapidly. So taking those red areas and really crunching them down so that when you have to do those iterations, when you go through what you do, or if you have hellishly large data sets that need lots and lots of crunching, it actually happens in a reasonable time. I was dealing with a customer up there middle of last year when COVID wasn't as much of an issue as it is now, and they were talking about how they only had rather small systems, and what it meant was breaking up their data actually gave them really big problems, because if they trained and broke up their data into smaller segments, they actually got different answers than if they could aggregate it all in one big memory set and process it all in one hit. So they were actually after systems at scale just for that initial processing, not for the long-term inferencing. So there's things that come into what you do here as a scientist, data scientist, that really change, and our infrastructure is designed to optimize that. So which is really important. Ken, I'll hand back to you for the first part of this.
Yeah, so I might talk about the left-hand side. So use cases, again, back to think about the art of the possible and the what if. So Exemplify is a IT services company. We're rapidly growing, probably one of the fastest growing, kind of sitting at mid-tier below the SIs, but above boutiques, above those that only offer one kind of platform or service, etc. We've got a few of those, and as I said, it's great to be able to partner with NVIDIA, arguably the world's largest and best, not only GPU manufacturer, but also how they're thinking about the software on top of the GPUs, how to make it accessible, how to ensure that data scientists can get into the containers and start using from day one. So from our side of the house, when we think about use cases, and this is just a little snippet of a glossy we produced as we're thinking about what we're doing in the future. The use cases are many, and here, I mean, we've got automation efficiencies. So everything from route planning in terms of automation, automotive and self-driving cars, self-driving freight, some of the kind of stuff that Transport New South Wales wants to be. Sorry, Andrew.
Okay, there's a question online. What is a GPU?
GPU. Off you go, Michael.
GPU. Okay, so the GPU is a graphics processing unit. So at its core, a GPU is somewhat similar in structure to a CPU, but it does things in a different way. So it does mathematical calculations, but it's very heavily focused on vector work and that sort of stuff. So we've got the ones we're talking about here, and you can actually sort of see them at the bottom of the slide. Those graphics processing units are part of purely computational workloads, and they're actually done at scale. You can actually see just above that, probably a bit small for you, apologies, but the picture just above that GPU is what we call our DGX A100. So it's got 8 of those GPUs connected together over our super fast bus. They've each got 80 gig of memory, and that all operates as a cohesive whole, and you can scale that up as big as you need to. That GPU, as I said, we run a whole bunch of software on top, which I'll come to in just 1 second. So yeah.
Maybe, and also the pedigree of NVIDIA from where NVIDIA grew up, and why is it perfectly placed for AI and algorithms, mate?
Yeah, so the joke is usually when I'm standing in the room, and I wish I could be in Canberra, but I'm in Melbourne, so annoying. But I usually make the joke, my mum tells everybody that her son works for a gaming company, which is technically true. But the reality is that the majority of our work is actually done, or majority of our GPUs actually do work as compute-oriented workloads. So pretty much every GPU you buy of our current generation, even the previous generation, it's got our general purpose cores that they can do graphics. It's also got dedicated AI cores on it. So we've got custom dedicated cores just to do the AI work. There's something called tensor maths, which actually plays into that. And we've also have ray tracing capabilities as well, which is more on the graphics side of things. So we've had this computational engine available since about 2008 called CUDA. You can see it listed there just above the systems. And that's what Alex, I think it was Krzyzewski, leveraged in 2012 when he said, hey, if I can use GPU rather than CPU to do my computational workload, what happens? And his computational work went from taking several weeks down to days, and now it gets optimized. And AlexNet is still around for testing. The other thing we do, even though we've got a variety of different GPUs that we've got in different formats and form factors and that sort of stuff, ironically, we actually have more people nowadays working on software than we do on hardware. And that's actually the stuff on the top right over there. So our CUDA framework, computational framework, underpins pretty much everything we do. And there's some other stuff there around fast storage and some offload onto our network cards and stuff. But above that CUDA framework, we've got stuff for high performance compute. We've obviously got the data analytics and machine learning, and then we've got the dedicated AI stuff. And the AI stuff, for those of you who've gone hands-on with AI in the past, you're familiar with Google's TensorFlow, there's MXNet, there's Cafe2 from Facebook, there's a Microsoft Cognitive Toolkit, and dozens of other frameworks, PyTorch, all the rest of it. We've taken that software, optimized it for GPU, and we make it available as a framework. So when Ken talks about the kit, it's not just a case of, hey, here's some GPUs, it's a blank server, good luck and build it. All the hardware is there, the network and plumbing is there, and more importantly, all this AI software framework is there ready to go, so that you actually have the latest and greatest new bits and pieces. And we've got some automated, basically GitHub library to update those. On top of that, we've got, I mentioned before, our medical library, Clara. We've got other ones that do conversational language, Merlin, Jarvis, Nemo, and a few others. We've got some stuff for security analytics over CCTV called Metropolis for smart cities. And then there's a dozen other frameworks as well. Again, so that you as a data scientist, if you want to build something, you don't have to go through every single piece of code right to the bottom of the pile. You can actually start at a higher level and leverage the toolkits and frameworks we make available, as well as the GPUs do the processing, and everything gets super, super fast. It doesn't necessarily have to be deployed on this kit. This might be scaled you do the training on, but you might deploy it on some really thin edge stuff, somewhere in a remote area. So we've done some work, for example, with University of Wollongong, and they've got some flood detection systems and a few other bits and pieces that actually work on basically something the size of a Raspberry Pi, and it can go bigger. Same software, fully transportable. So from the base level of the graphics processing units doing the maths, offloading those, as I said, large numbers of cores, massive parallel programming, the same stuff that's used in high performance compute for weather and all that sort of stuff. That's what can accelerate your GPU stuff as well. That's the combination of frameworks that we really sort of make available here to hopefully make your life a bit easier and faster.
And the special offer on for this evening is that if any of you have teenage age children that need some new cards for their gaming, that we can make some. Okay. Now, apparently they're short supply, aren't they? Right? Is that
and I wish my favourite part of my job is doing giveaways, and unfortunately supply is hard. So I'm sorry. You can just set me up there. All good.
But yeah, so that's, and for me, that's one of the fascinating parts, right? So that pedigree of gaming, making sure those refresh rates are there globally is just lends itself so well to the algorithmic kind of computational spinner really fast.
In fact, for those of you who've got kids at home who are doing some of the latest gaming, ask them about when they get home something called DLSS, which is deep learning subsampling. And basically what it means is instead of making your graphics card work harder, we can actually use AI to upscale and smooth things. So you go, basically gamers are all about frame rates. So it actually uses the AI engines on any of our cards, but gaming cards as well, to actually accelerate what people are seeing. But it's not so much graphics processing, it's actually AI work that's doing that. And we actually trained that on our supercomputer back in Santa Clara. So even the gamers using AI nowadays, so it's pretty cool.
So this slide is really trying to bring it all together a little bit in terms of, well, we talk about the art of the possible, the what if, the different use cases, the areas in which we think there's immediate value in which, again, with the appropriate NRV infrastructure, with the software across the top of it, with some appropriate training, etc., that a lot of people out there, a lot of professionals like yourselves as data scientists or people work with data, AI becomes approachable, becomes the threshold or the barrier to entry is no longer there. It's easily accessible and really readily accessible at the same time. And so us as a company exemplify a couple of things we're doing with NVIDIA. One is we're going to be looking to offer to the market in the near future, very near future. So we talk about the GPUs and the DGX boxes and whatnot. We're going to be offering GPUs as a service. So we're going to be offering a subscription lease on demand kind of service. So you can buy some GPUs for a month, you can buy it for 6 months. If you have a research project, or if you have a big problem you want to crunch through, but you don't want to have to invest in the full infrastructure and deploying yourself via a cloud instance, we're going to be able to offer GPUs as a service, and we're going through all the protocols to get that up to a protected level. So, and it's all going to be sovereign based as well. So that's the kind of things we're up to, and that's why it's great to be able to partner with Exemplify. In addition to that, we're going to be offering a training facility with NVIDIA to be able to train up whomever, to be able to fully maximize all of the software and obviously what the infrastructure can provide in terms of what it does. And part of that will be we're going to have a deep learning facility. We're going to create one in Canberra, in the city. So a place that you can come do your training, you can even come and throw problems at it, and use some of our staff and some NVIDIA staff to help showcase what and how AI can be used for your success. So that's kind of a couple of the teasers coming up from and selfless plugs, thanks Andrew, around what Exemplify and NVIDIA, what we're doing together. But obviously there's tons of things on the websites, on NVIDIA's website, really powerful videos, get goosebumps every time I look at some of them. Is there anything else on this slide you wanted to cover off, Michael?
No, I think we've sort of covered up framework, both the business and the technical side. Yeah, maybe if there's some Q&A there, we'll tackle that.
Yeah, so is there, what's the next one?
That's it. So
That's it.
Next one is the joke slide with waiting for Q&A. It's got to finish with a laugh.
Yeah.
So,
this is where I'm Ricky, right? Is that what it's on?
No comment. So after setting me up, no comment, Ken.
Okay, yeah, thanks. Excellent. So I'm Ricky in this one, I think. But we'd like to understand more about your challenges and through a Q&A now and or afterwards. So
yeah,
we've already had one question. GPU, great question. Other questions?
So any questions online? If you just put them in the chat, I'll read them out. Anybody here got a question?
So one question is that how differentiate? So you have already built the platform and you're providing platform as a service. what I understand. Is that understanding correct?
Yeah, so as IT services company, we work from data centers through to apps dev, the whole kind of gamut. So we're working with NVIDIA as a partner we'll provide all the infrastructure, and we're setting up in order to be able to, as I said, get to that protected level through CDC and others. So it's going to be completely sovereign as an offering. We're going to be providing the enabling infrastructure to be able to offer it as a service on a lease or subscription model, and it'll be using NVIDIA in terms of their infrastructure and compute power.
So my next question is that what is the difference between, let's consider, I can get all the services into the Azure, I can stand up NVIDIA using NVIDIA card, I can get the GPU and everything, I can spin up machines as well. So what is the difference between your service and whatever the service we are getting either from Azure or AWS or from?
Yeah, so I can probably answer, Michael, the bit about the subscription lease and why that's cost effective. But do you want to talk about Azure and AWS?
Yeah, so it's a common question we get asked, especially when people want to kick off, because cloud is awesome. You don't have to buy anything; you just rent, right? So it's a very common question that comes up. So I'll give you the answer of one of our customers here who bought infrastructure similar to what Ken's offering. We actually said, "Oh, why didn't you try the cloud?" They said, "Oh, we did try the cloud." And we said, "Oh, okay. Well, why did you buy a kit then?" They said, "Well, we were given about $150,000 for the credits. We accidentally left some stuff running and it blew $50,000 overnight. So we thought we can't afford to do that twice. So we actually bought kit." Short story. That's one customer. We've heard that from two others. What we often get from customers is when you're starting off at a small level, it's actually quite good. But the GPUs in the cloud, two things. First of all, in Australia, they're usually N-1. So they're usually a generation behind, which means you have to buy more kit. Data sovereignty is often a very, very big concern for many of our customers. And as Ken was just talking about, having a protected network access means something very, very significant in the federal space. But more importantly, most of our customers tell us that if you use your infrastructure fairly heavily, so let's say about 75, 85% of the time, generally speaking, it's about a 9 to 12 months return. So up until that point, cloud's cheaper. After that point, and if you were buying kit, you'd usually buy it for 3 years, then it actually turns out to be cheaper to buy the kit after that 9 to 12 month period. Having said that, if the sort of GPU as a service, and the reason we've partnered with Exemplify is precisely this: a protected, secure, local, benefits of cloud, but without any of the challenges of cloud. And it's right there in Canberra at AusCloud, right? So this is different from a few different perspectives, but security being a key part of that. Okay.
Yeah, I suppose the only other part of that is, I suppose, the commerciality. So if I was sitting in a CFO role or sitting into a CEO role and thinking about, okay, how much are we really going to use this infrastructure when we have to think about a 3-year life cycle, etc. So getting into the space, once you're in and potentially you are being the Google in 5 or 10 years down the track, then it's appropriate. You buy your own kit, you do whatever you want. But to get there, to actually build up your business cases to understand how best to use the possible or that what if, we'll be in a spot where we can offer, if you want one GPU for 1 month, sure, we can do that. If you want 5 GPUs, you can have 5. If you want 5 months, 3 months, 2 months. Again, if you've got a research grant that lasts for 2 years or 15 months, and you only need that processing time for 9 months of that, then just buy it for 9 months and you don't have all that pain. So effectively what we're trying to do is we're trying to take that pain away from the enabling infrastructure, all that sort of stuff. And the way in which we're doing is obviously by cloud, AU cloud, C2C, up to, as I said, going through up to that protected level. So it's really the commercial offering. But if you're big enough, then I mean, you can buy your own.
So you got the platform, and as I mentioned from Michael.
Michael, yep.
Yeah, Michael. Okay, so you have the software available as well onto your platform, so which can be easily used.
Yeah, so all the
or you're just feeding the GPU and then someone has to set up everything.
No. So that's I think one of the main points Michael made, and Michael, if you'd like to reiterate, when in the case of NVIDIA, and that's why we're excited to be partnering with NVIDIA as a small to medium company here, right? We're 80 people in Canberra, and we've got probably 90% of our staff are MB1 or PVs. We're really privileged to be working with NVIDIA because it's not just the boxes or the tin that they've got, it's all the software they've been building up and those libraries and those containers. And hence with the training courses, it actually makes it a lot easier to be able to start using it from day one. Michael, do you want to expand on that?
Yeah, and I'm just going to extend this as a question in the chat window as well, just typing for Sharon. So all the software's there ready to go. So if you wanted to build a deep learning battle box for yourself, either on a server or desktop, whatever it would be, you'd leverage the same software that Ken's offering here, obviously at a different scale. This is, for the larger scale we can actually do here. So we've got something called our NVIDIA GPU cloud, not a cloud, it's actually a catalog. Marketing got involved in that one. So that software is all there ready to go. So you can connect in and start crunching stuff immediately. You just need to copy your data on and pick the sort of neural net you want to train with. Do you want PyTorch? Do you want TensorFlow? Do you want whatever it is? And you can actually create your train network out of that, extract that, and then deploy it elsewhere. Should you want to do so let's just talk a minute about how businesses often do things, which is build or buy. So there's two interesting aspects of this. So when you build your own framework, we've got quite a few customers doing this in Australia, you might have something that is absolutely unique that nobody else is going to create for you, right? So what you do is you do all the training and then you extract that out, and that becomes your intellectual property that you've trained, right? So it's a custom trained network that can identify invasive species. It can identify whatever it may be, fraud, cyber, whatever it may be. And you can then apply that on the same kit for what we call inferencing, or you can do it on your own kit. So you can also do something else where you don't build your own, you buy. You buy software off the shelf. So you might buy cybersecurity software and you feed your stuff through a small portion of Ken's kit, and you run your software on that, or that purchase software on that. It might be 1 GPU, you might need 3, depending on the volume of data and the complexity of the AI model. And that would be a custom licensed API that you would have bought from somebody. They're often done in the security and safety space. Are people maintaining social distancing? Let's track 15 video feeds. Or has a car loitered outside our businesses after hours for the last 3 weeks? Let's just get that license plate and track that down. People, masks, cybersecurity, fraud detection, whatever it may be, whatever you bought off the shelf, you can also apply here. So we don't have that software ready to go, but if you buy that, you can deploy that here as well. So everything's fully ready to go, as I said, exactly as if you built your own infrastructure from scratch, enterprise or otherwise, and you can apply pre-built models and AI software to this as well.
So there's one question online, Michael. Do you want to?
Which one's that? Is that
the one about can traditional data warehousing feed into your inputs?
Okay, so that would be a plumbing answer. So if you want to feed data in, it's really just around storage. And again, as Ken said, there's protected and non-protected data and how you want to handle that. That can be just plumbed in so that it's in the data center. If your storage is nearby, great. If not, it has to be fed in and the plumbing's there and the data would stream through. If you're training a model, it's pretty simple. It's a large data blob. You transport that across, you do the training, and you destroy it afterwards. Just wipe those disks, no problems at all. So depending on which part you're going to do, if you're doing that application of training that you have, or application of software you've bought, so the inferencing piece, that's where you'd actually run your data stream through Ken's kit. It would then come out with the answers that you're after. Fraud, not fraud, risk, detection of, I don't know, medical assessments, whatever it may be, and then you'd get your answers back through an API there. So it's just data is just plumbing, and these boxes have a fair bit of storage on them, but there's storage co-located for precisely these reasons.
So another question: what are the challenges in modeling and storage of AI data in the data?
Yeah. So we've had to create a special bit of software called Magnum IO. I always insert a Zoolander joke at this point, but it's better if I've got a slide for it. So what this is designed to do is basically speed of access from the GPUs, bypassing the CPU entirely and getting the data direct from storage. Because the biggest challenge you can have with these big boxes, and this is why traditional IT struggle with creating this infrastructure, is your GPUs are starved. They're actually not getting the data as fast as they need, so they're actually underutilized. So in terms of design of something like this in the data center, that's key, which is why we've gone through best practice and our architecture, and we own the networking stuff for this as well. But more importantly, across that governance piece, this is where we talked about federated data before. So, where you get your data sources from to train, what they look like, how you have to handle those, health data versus, legal-based data. There's, GDPR considerations, depending on where you get your data from, how you make sure that data set is representative. For example, how it would handle if it was, say, for example, human beings, catering for people of color, height differences, people with glasses, people without, being able to cater for edge cases for people, all that sort of stuff needs to be taken into account. And that governance of application algorithm is another layer on top there that is really important for business, very, very important, which is why so many large AI firms, ours included, have actually hired ethicists and people like that to consider things, so, yep.
Okay. So there's one more coming. What are the base skills needed to operate, train, data science stream, data engineering capability, linguistics?
Yep. Okay. Good question, Sharon. So I'm going to fall back to a comment that Ken made before. So we actually have an organization called the Deep Learning Institute, which actually conducts training, and we're setting this up in conjunction with Exemplify in Canberra because there's a large sort of need for that there. There's a couple of basic things you can work through to get up to skills. We actually have courses that take you through computer vision or natural language processing or industrial inspection or anomaly detection or all sorts of stuff like that. So we have our mechanisms to help you get trained. The great thing for me, I actually left science and did humanities, again, much to my parents' embarrassment. So the maths freaks me out. Having said that, you can actually go through the process of this sort of stuff without knowing all of the 3D weird tensor maths and that sort of stuff. So going through this, you just need the kit and you can walk through this. And there is a process to learn this, and that's one of the things we're trying to stand up here as well.
And a question what we'll be offering into the market will be, obviously there's tons of online stuff via NVIDIA at the moment, but some of that face-to-face training, again, where we're going to have some DGX boxes in our facility and we're going to be playing with them in sandpits, that kind of thing. So that's definitely a key part of where we see that ecosystem of enabling people to access it. That training facility and deep learning facility is going to be key for us. So that's one of the things we're going to be bringing to market very soon.
Yep.
Another question, is the IaaS you're offering include all the compute elements required for machine learning, or is it just focused on GPU? Also, is it hosted in Australia or offshore?
Yep. So that's one of the key points is it's all hosted here. So that's how we're going to get that certification up protected level. So we're working with AU Cloud and CDC to be able to offer it as a full sovereign service. So we're calling it GPU as a service. Again, we haven't launched it to the market yet, but it's getting very close. So it is not only just the infrastructure, it's also all that software. It's all of the, I suppose, the ability to get started in what NVIDIA has created on top of the actual tin at the same time. Right. So it all comes as part of that package.
Yeah, and just as a sort of a more detailed answer to the first part of that question around, is it just machine learning or just focus on GPU or you can do machine learning? It does machine learning, absolutely, it does machine learning, and deep learning is a subset of machine learning. It's GPU accelerated machine learning. So one of the most common machine learning frameworks is called Rapids. We've taken some code out of that and GPU accelerated it. So yes, machine learning, just faster, because that's what the GPUs do. That's why they're there. They're not there because they look fun. They do look fun. They're cute and gold and shiny with a bit of green on top, but they accelerate the work. So the machine learning you can do there, faster, better, and higher. A bit like the Olympics, really, but without COVID. So yeah, sorry.
Question.
Have you got any examples of where you're working locally with government departments on their problems and solving some of their problems?
Yeah, so yep. So NVIDIA, in terms of use cases around Canberra, which of those can you talk about at the moment?
You make it hard. So there's a few organisations that have gone their own way. So I just think DHS actually have some very, very sophisticated bots, customer service bots that they're doing some bits and pieces with. There's obviously some other agencies that I can't talk about that are doing things like around fraud detection, cyber fraud and cyber detections and cyber security and that sort of stuff, because that's a big issue at the moment. It's been in the press a lot in recent times. And I think that stuff's semi-public on their websites, but we underpin a fair bit of that as well. And then there's the regular stuff, so I think financial fraud detection, that's the stuff which can blend into anything from tax awareness to that sort of stuff as well. So I can't comment on specific projects, but as it also depends on whether we're talking about this stuff being customer focused, which is a chatbot is a chatbot. Just depends on what your domain of knowledge is. So it could be medically based, Medicare, or it could be process based if it's Service New South Wales or something like that, or if it's inward focused on processes, right, or finding patterns and that sort of stuff. So lots of different projects going on. I would say some of the federal agencies are much more advanced than others. Some of them are like really off the charts good. And a lot of that was to do with upskilling and a bit of iterative learning and that sort of stuff with processes as well. But it's come a long way in the last couple of years.
So as an overarching statement, I'm sure Michael wouldn't mind me sharing this, there's lots of government agencies using some of the kit in terms of how we're going to be bringing that in a different way and enabling people in a different way. That's not in the market yet, so I can't offer you the example. We do have our first client signed up, ready to go in terms of deploying their AI algorithms through what our offer to market would be, which is the GPU as a service. And they do service some government clients at the moment, and they've been in the media recently as well. But certainly we welcome any kind of one-on-one conversation where perhaps we could get under the tent a little bit more around what we can share and what NVIDIA can share directly. Yeah. So a question here at the front.
Yeah. You mentioned before about the barriers and then starting to disappear now. So what would then be that point where you'd start the AI journey?
In terms of what's stopping people on that journey?
Or probably what are the key factors that you'd want to have in place? What are the sort of things that you want to have mature enough to be able to start?
So I think that's comes back to some of the points around the governance aspects, around understanding the commerciality and the return. So how are you going to define success in terms of how you're now using AI in different ways? So are you changing a business outcome or a particular outcome for a department? Are you doing that because you're now doing it quicker, or you're actually having a different impact? So I'd be making sure that the business cases are set up appropriately with the governance, making sure that, as a dominated by government town, thinking about how others are already using it and where there is leverage, where there could be whole of government kind of collaboration and sharing. So some of those points that we went through around making sure you set up properly, and then using the ability to almost try before you buy to make sure the business cases stack up, so that it's pretty clear and warranted as to why this is such a good thing to be able to start leveraging more, and then build out from the easy use cases to the more complex or the harder ones. So really that ecosystem setup.
Yes, so I'd echo that too. The first thing that a lot of businesses do is, what are our peers doing in across the world industry? What use cases and how they're trying to apply this as a solution. Once they understand what that may be, unless they're crafting something unique, and there's a few organisations in Australia who are doing some really globally unique things. At that point, it's a case of, all right, what is our data readiness? What are our skills capabilities? And then how do we have management overlay of the top of that to actually run through this process? Infrastructure is a consideration, and this is where obviously Exemplify can eliminate that infrastructural concern. Sometimes, GPUs, a server with GPUs is more expensive than a server without, but it can do more. So the question is, okay, do we just go there and start that way, and then maybe we use that as our cloud because it caters for all we need, or do we want to buy our own in-house kit? And sometimes that can be around legal and data sovereignty concerns, but I don't think that should be much of an issue. So that's usually the rough process that people go through, informing themselves about the industry and how AI applies to it, then their capabilities, and then actually the ability to execute. It's probably the most common ones. There is a question in the chat window around... how
much time we got?
About a minute.
About a minute.
Okay.
There's one more question that runs off, so perhaps we'll go through them really quickly.
Yeah.
All right. So one came up about natural language understanding, or we call it natural language processing. This is the ability to quite literally understand contextually language. So, for example, the Russians gave up on language translation with AI in the 80s because a hydraulic ram would be translated as water sheep. Right? Technically it's accurate, but that's not contextually accurate at all, right? So natural language processing builds understanding in a domain-specific area. Think medical, think legal, think security, think governmental and policy, et cetera, et cetera, et cetera. And natural language processing is where you train things. We've got a customer in New Zealand doing this to preserve Indigenous language throughout the Pacific Islands. So they've got some really complex stuff they're doing, but the ability to speak natural language to a computer as an interface, or for it to understand written text and large bodies and extract meaning from that. So it's often being used, for example, in algorithmic trading, whereby you get a bot, you send it off to half a dozen information websites, it gathers understanding and context from what's happening, figures out which shares to buy, and off it goes, right? All through a natural language processing or natural language understanding. So this system is fully equipped to do that, both to apply it and also to train on it as well. So we've got some engines there that help you with natural language capabilities.
One last very quick question from the audience here.
Yeah. So I just wondered, because most of the organization, the IT and the business, there are two different entities, they don't talk to each other.
Yeah.
Okay. That's the basic fundamental problem. And see, look, we know that using the AI, a lot of things we can do it, but business doesn't know what AI can help them out and everything.
Yep.
What would be your strategy in order to overcome that barrier, and because unless or until business know, oh, these are the things we can do it, then they can start using your platform or something. So what would be your strategy for that?
So obviously, in a government town, things like risk are up there. So being able to showcase how risk is mitigated, how there's no change in risk profile in terms of just thinking about how to solve problems in different ways, thinking about the commerciality of it, thinking about the time and being able to use talented people for that grey zone as opposed to the black and the white. All those elements of the business case, and then how you work it through either a proof of concept, proof of value, and basically the ability to scratch it, to look at it, to see the interaction on it. They're the traditional ways to break down those silos between business and IT.
How will go? Because once the customer comes to you, then you can verify all this. But before that, how you can approach the customer that, oh, AI can help out, or how you do the showcasing to them.
So and part of that unashamedly is going to be the deep learning facility we're going to have here. So the ability to come in and have a look at it. The fact that the privilege again of partnering with NVIDIA is there's already use cases around the globe in pretty much every type of government department out there. They're already using it, and we can be showing the ROI, and we can be putting people into contact. So the fact that we're prepared to invest, and we're both as companies investing in that facility, we're putting our skin in the game to say, hey, here is a different way of doing things and different way of solving a problem. How to translate it into business case? What are your reference sites? And great question. It's always a case of, well, who's using the Canberra already, right? So how do we build that up when we don't have necessarily the first one? Although, as I said, we do have an AI company that's signed with us already that is already working in government, and now they're going to be using our offering as opposed to how they traditionally did it. So it's the usual kind of challenge. It's probably no different in the answer, but I think the ability to walk through it and to sit down and have a look at it is a good thing.
Okay, well, that's it for questions. Thanks a lot, Ken and Michael. That was very interesting. Yet again, the world is getting more complicated. We need a few more experts around the place. So thanks a lot. And,
thanks a lot.
Thank you, guys.
Thanks everybody online. Thank you. So, right.
Andrew's hanging up. Excellent.
There we go.